Here are two strings, brute and groot. What is the shortest single string that contains both of them as subsequences? That question is the shortest common supersequence. Formally, given two strings, S1 and S2, we want the shortest string that has both of them hidden inside it as subsequences. A subsequence keeps order but is allowed to skip characters. The lazy answer is to just glue them together. That always works, but it wastes every character they share. The shortest supersequence writes each shared character only once. So its length comes straight from the longest common subsequence. Take the total, n plus m, and subtract the overlap we don't need to repeat. Length equals n plus m minus the length of the LCS. For brute and groot, both length 5, their longest common subsequence is RT of length 2. So the supersequence has length 5 plus 5 minus 2, which is 8. Knowing the length is nice, but can we actually print it? Yes. We build the same LCS table and walk backward from the bottom right corner to the origin. At each step we ask one question. If the two characters match, we emit that shared character once and move diagonally. If they don't match, we follow the larger neighbor up or left and emit the character from that direction. Watch the path. Every diagonal step contributes one shared letter. Every straight step contributes one unique letter. This is exactly the print LCS backtrack, except now we emit on every single move. When one string runs out, we're not done. We flush the leftover tail of the other string, then reverse everything, because we built it backwards. Here's the whole method. Fill the table, backtrack while both indices are positive, drain the two tails, and reverse. Match moves diagonal, mismatch follows the bigger neighbor. The cost is the size of the table. Time, order n times m. Space, also order n times m, because we need the full table to trace the path back. Two traps to avoid. Don't emit a matched character twice. It appears once. And never forget the leftover tails after one string is exhausted. So here is the big idea. LCS and shortest common supersequence are mirror images. LCS keeps only the overlap. The supersequence keeps everything but merges the overlap once. Same table, opposite emission rule. Next, a counting twist. How many distinct ways does one string appear inside another? That's distinct subsequences. See you there.